There's no way around diesel engines. Take a trip with us on a journey through an engine. Sophisticated technologies mean economical and clean engines. The engine runs smoothly thanks to the perfect interaction between its components. Inside the engine, fuel and the oxygen in the air interact to transform chemical energy into work. Follow the airflow through our engine and discover all of the key components that will help to lower emissions in the future. These components are the injection system, turbochargers, the exhaust gas recirculation system, the engine electronics, and the exhaust gas aftertreatment system. And off we go. First, the engine takes in air. It flows through the air intake pipe to the turbocharger, where it is compressed to pressures of up to 5 bar. Hot pressurized exhaust gas drives the turbine up to speeds of several tens of thousands of revolutions a minute. R&D specialists are constantly working to develop higher charge air pressures so that the engine output can be steadily increased. Turbocharging is a key technology. With two-stage turbocharging, optimum charging efficiency is achieved by using a charge air cooler located between the two compression stages. The air heats up significantly during compression. It needs to be cooled before it enters the combustion chambers. The charge air coolers perform this task. Cool charge air helps to reduce the emissions created during combustion. MTU works with its suppliers to develop highly efficient and compact solutions for charge air cooling. The cool, compressed air enters the combustion chamber through inlet valves. In the combustion chamber, the air is again compressed by the piston. The injector sprays in fuel which mixes with the air. The mixture has to burn cleanly. This is achieved by precision injection and by a piston bowl shaped to perfectly match the injection flow. MTU has decades of experience with efficient combustion processes. That's why the exhaust gas which leaves the modern combustion chamber is extremely low in pollutants. In future engines, some of the exhaust gas will be rerouted back to the combustion chambers again. The exhaust from several cylinders, the donor cylinders, is used for this purpose. The hot gas from the donor cylinders is cooled and reintroduced into the combustion air. The inlet valves allow the combination of exhaust gas and fresh air back into the cylinders, where it mixes with the fuel injected to allow combustion to take place. Combustion processes which use exhaust gas recirculation need an extremely high injection pressure. This makes it possible to achieve low levels of nitrogen oxides together with low particulate emissions. The low-emission exhaust then leaves the combustion chambers and passes on to the turbocharger. The energy from the exhaust stream drives the turbocharger, which in its turn compresses the fresh air, completing the perfect circuit. Today, MTU engines already utilize extremely clean combustion processes. In future, many of these engines will also be fitted with particulate filters. Here, the soot will initially be retained by the filter before being burned there under controlled conditions at higher exhaust temperatures. That is how we ensure that the exhaust leaving our engines is clean, and that MTU meets and exceeds the environmental standards set throughout the world.